Don't mind the orange reflection on my black screen. I'm wearing a fluorescent orange shirt that I usually only wear in the summer, but we've had some pleasant weather here the last couple of days, unlike the time, the couple of weeks before that. Anyway, today we're going to be talking a little bit about emission stuff, and some of that stuff you may know, some of it not. A lot of times what I try to do is I try to cover stuff in a slightly different way than what it's usually taught, so that maybe you can pick up a little extra something that you didn't expect. And so here we go. Pcv system since 1961. The first, from some research that I saw in an old set of encyclopedias, the first PCV system appeared on the, I think it was the 61 or 62 Corvair. And they basically used to have a draft tube that was cut at an angle that would evacuate the crankcase while you were driving down the road. And in the cities, it turned into a real problem because they had a lot of heavy smog hanging around. So one of the first things they wanted to control was crankcase blow-by emissions. And so some smart aleck decided, hey, we can just recycle that back through the intake and take care of it. Keeps it basically self-contained, not a bad idea. I think this typical Pcv valve has got a spring-loaded, pintle here. That basically when you're a high-speed low manifold vacuum, you got max flow. Low manifold vacuum lets the spring push that all the way back to where it's smaller. If you've got a backfire from the manifold, it shuts that off, So basically you got, backfire in the intake, not in the intake, in the crankcase, it shuts that off so it doesn't go into the intake manifold. At idle speed, you've got PCV, but not very much and all that. So, but anyway, there's your PCV diagram here. The oil temperature is hitting about 212, and so that's going to steam all the water and stuff out of there. It's really important that people don't take their cars and drive them without letting them warm up, because if you drive a car and you don't let it warm up, it sludges the engine up really, really bad. For long years in this part of the country, they claimed that Quaker State oil was supposedly the problem, but that wasn't so, because Quaker State's about as good as any oil. Some of the old farmers used to squawk about that. But the point is, a lot of people, unless you're living in Texas somewhere where you live a long way from the store, would be driving just little short distances to the store and back, and they'd never let the vehicle warm up. Or if it's running too cold, you'll wind up building you're making a gallon of water for every gallon of gas you burn. And so as you make that water, some of it goes by into the crankcase in the form of blow-by. And if you don't warm it up so that it will steam out of there and the PCV valve can carry it out as vapor, then it winds up sludging up the engine. And sometimes, and like I say, not all PCV systems are a PCV valve. Sometimes they'll just have a little small orifice, like on some of your Jeep 4 liters, and on some of even your Chevrolet pickup engines nowadays, they've got a device that looks like a regular PCV valve, but it's just got a little tiny hole in the bottom of it. And then some of your old Asian makes used to just have a little vacuum nipple on the on the valve cover, and from the intake up to there, it would just pull a small vacuum on there. If that PCV system's working right, though, if you go to the closure hose on the other side of the system, which would be right here, then you ought to be feeling a little bit of vacuum on that closure hose. And it's supposed to be able to cover that unless there's so much blow-by from the rings that it can't handle it all. But if that gets clogged up, it'll build pressure in the crankcase. If it's clogged here and it's clogged there, it'll build pressure in the crankcase, and it'll blow every seal in that engine. And I have seen them where every seal was blown, the guy replaced all the seals, didn't do anything to find out why they all blew. They just figured it out, a bunch of leaking seals. So if you build up crankcase pressure. Also, if you see this kind of thing on the oil filler cap, that's a dead giveaway that you got an issue with your PCV system. Some people think it just means you got water in your oil, and you do, sort of, but it's not coming from the coolant jacket. It's basically condensing in there. And the more of this kind of stuff you have, the worse the sludge is. Now, Toyota, around the turn of the century, they built some engines that didn't have the PCV system wasn't working right, and you had this kind of situation right here. This is an actual Toyota engine that was replaced at the local Toyota dealer because they didn't, the PCV system wasn't working right, and it sludged it up so bad they just replaced the engine. And that was what Toyota was paying to have done for a while, but that's a picture of actually one of those that did that. Alright, sequence of events. Engine starts, engine vacuum's created, PCV valve regulates flow through the crankcase, filtered air enters the engine and carries blow-by gases enters the intake basically. Carries blowback gases, removing fuel, vapor, vapor, fuel, or water from a crankcase. Now you might remember on some of your older cars there was a little closure hose going up to the breather, and it had a little a little fiber filter inside that round air cleaner. That was supposed to keep dirt from being pulled into the crankcase as the PCV system pulled air through there. A lot of people didn't think that was all that important, and they just throw it away. But if the PCV system goes sour, it winds up pushing it back the other way. Now the newer vehicles, they don't have a PCV filter because they just pull filtered air out of the air inlet tube. And the reason they do that is because the mass airflow sensor needs to be able to record the air that's being pulled through there. As a matter of fact, you can watch your fuel trims, and you can take your oil filler cap off if you're watching your fuel trims, and you'll see your fuel trims begin to change because suddenly you have unmetered air going in through that oil filler cap. So think about this. You can have a fuel trim imbalance if you've got a bad gasket on your oil filler tube cap on some vehicles. All right, let's move on. EGR has been around since about 1972. They differ in design and feedback. Now, back in the olden days, back pressure had to be on the vehicle engine, the exhaust with this little, right here, there was a little double diaphragm in there. And the back, it had a hollow stem going up here, and that would basically, when there was back pressure in the exhaust, that would close this and allow the EGR to work. If there was no back pressure, you'd get no EGR. If you got no EGR, combustion chamber temperatures were higher, and sometimes you get pinging, and you might even get engine damage. Now, that's not so much the case anymore as it once was on some vehicles. And you couldn't categorically say that any time your EGR wasn't working, you were going to destroy your engine. But on some of them, you burn a hole in the top of a piston. Back in the old AMC days and all that stuff, American Motors. These right here is a linear EGR valve that basically has 5 wires going to it. 2 of them operate the motor, 3 of them are a potentiometer in there, and it basically gives you feedback. You can actually, if you got a good scan tool, you can command that EGR valve to open and look for indications that it has open. Listen for it. If you open the EGR valve and you know it's opening, but there's no change in the sound of the engine, then typically that means the EGR passages are clogged up. And sometimes you have that. I'll show you a picture of that in a minute, unless I forgot to put it in there. On the Ford, they have a little orifice in that EGR tube, and they got a pipe coming off each side of it. That DPFE sensor, when they used to have the metal ones on there, would read about 0.6 of a volt at rest. The newer plastic sensors read about a volt. But basically, it's a feedback mechanism that's been around ever since 1991 on the Lincoln with a 4.6. And that tells the PCM how much EGR to put in there. And exhaust gas goes through this tube. The reason it's kind of got a long, skinny metal tube a lot of the times is to cool that exhaust off before it goes into the intake. Because basically, if you're cooling a combustion chamber, why do you want hot exhaust? Even if it's hot inert exhaust gas, it won't burn, which causes the combustion chamber to run cooler. Why in the world would you want to put hot gas in there? Your diesel engines, it's got EGR on them. The newer diesels, they have EGR coolers that lower the temperature of the exhaust something like 800 degrees from the time it leaves the exhaust until it goes into the intake through the EGR valve. And incidentally, this is the clogged up passages I was talking about. If you open the EGR valve manually, if you have a way of doing that, and if it's just vacuum operated, you can, just use a vacuum pump or whatever. If you open the EGR valve and you know it's open and the engine doesn't change sounds and you don't have EGR flow, that throws you a PO401. You got to do something to clean that out of there. On some of the ones, it's got a separate EGR feed to each cylinder, like on some of your Nissans and stuff, and on some of your Ford 3.8 liters and some of the vans. If all of those are clogged but one, when you start getting EGR, it will actually kill one cylinder because all the exhaust gas recirculation is going into one cylinder instead of being divided between all 6 or all 4 or whatever. On your Nissans, you'll feel a little bit of a surge. If you unplug the EGR valve and the surge goes away, there's some little ports you can clean, where the EGR gas goes in there. And also, you'll get misfire codes sometimes. You'll see an injector drop offline because of the misfire that's happening. and it'll make you think there's an injector problem if you don't know what you're looking at. So if you got one that only starts misfiring when you crack the throttle, unplug the Egr valve, see if that goes away. If it does, you need to be looking to see if some of those separate ports are clogged up. And it'll actually, when you pull the upper intake off, you'll see a little Egr port feeding into each cylinder. It's got like a 6mm hole in it. Alright, sequence of events. PCM checks engine coolant temperature for proper engine temperature, checks throttle position and engine speed, opens Egr and monitors feedback to make certain Egr flows. Now on these diesels, if you open Egr, it gets really quiet. Doesn't sound like diesel anymore. But on a gas burning engine, it'll idle rough. The only time Egr is supposed to work is wide open throttle. The only time it's supposed to work is at hot idle cruise. If you're just sitting here revving it up, you may get Egr and you may not. If you're driving down the road, if you're cruising, you'll probably get Egr, okay? If you're wide open throttle, you won't. If the engine's cold, you won't. So you're basically warm part throttle cruise, partial loads, when you're going to get Egr. And that's when that's supposed to work. All right. Here, a question. If you charge a person for doing parts or labor you didn't deliver, is that stealing? It's a good question, isn't it? All right. If they paid for the work or the parts and you didn't do the work or you didn't install the parts, you stole from them. You know what, if somebody was willing to pay for an entire wire harness just to get the one little connector that plugged into the alternator, if you just clipped that one connector off and soldered it on there instead of putting that whole wire harness on there that they paid for, if they told you it was okay to do that and they were going to keep the wire harness, that's one thing. But if you just clipped it out, soldered it on there, and charged them for putting a wire harness on, you stuck them, you know, with the cost of the, you know, labor and all that other kind of stuff. Believe it or not, there are shops that do that kind of thing. All right. Evaporative system fights hydrocarbons that evaporate from the fuel tank by storing them and then drawing them through the engine when the PCM decides to. That's what this thing can be in various different places. On pickup trucks, it may be up there right under the driver's feet on the frame. It may be in the engine compartment. A lot of the time it's under the back of the gas tank. It can be all, you just got to find out where it is on the car you're working on. And basically what you got there is you have a vapor line that's going here, and see, there's your purge control valve. On the older ones, there's a little, when it got the vacuum from the ported vacuum from below the throttle plate, or above the throttle plate, it would actually operate this and it would purge it. Now this right here is nothing but a vent. Fresh air comes in there. Right? It's got a little cap over it, but it lets fresh air come in. And so you got activated charcoal in there. Those vapors are stored in there until that purging takes place. It keeps this from getting out into the atmosphere. Now these were on vehicles a long time, but when the OBD2 came along, starting in about 1994, and it was complete by 97, pretty much on everything, they started having to check the operation of to see if there was any vapor leakage. And the way they would do that is they would close this canister vent solenoid. They would use the canister purge solenoid to pull a little vacuum on the whole system. They would use a fuel tank pressure sensor, and they would, when it's holding that vacuum, that fuel tank pressure sensor is not supposed to leak up. Now, it will only do this test if it's between 15 and 85% fuel level. If somebody drives around all the time and they never have their fuel tank above a quarter of a tank or above, you know, a lot of times people drive it close to empty, they may not ever do an evaporative test. If it's always topped out on full, they may not ever do one. So it's not going to do it just any and every time. And some of them have natural vacuum leak detections, and, you know, Chrysler's got a, you know, a special little pump thing they got there. All these evaporative systems are different. This is a generalized deal. That pressure sensor you may have seen on your fuel pump is there for this purpose. And there's your little canister purge solenoid that likes to die on your Chevrolet pickups all the time. Canister vent solenoid is really important. And there's your canister back there. That's what it, you know, kind of what it looked like. And anyway, just give you a little bit. Fuel level sensor is really important too. You can get a code if your fuel level sensor is not working right. And if it can't trust that, then it won't do the test either. If you open your paycheck one Friday and find the payroll department made a mistake, gave you $100 more than you should have been paid, what's the right thing to do? Do you keep quiet about it and hope they don't notice, or bring it to their attention and let them decide what to do? If you know they made an error in your favor, you need to make it right. That's the only right way to do that. When I was working at the dealership over there in Dothan, one of the ladies in the office said I was the only one that would do that. when they made a mistake, I'd always go make sure that they took care of the problem, because I don't want any money that I didn't earn. Air induction reactor system since the mid-60s, mandatory in the early 70s. It's all about helping get rid of cold start hydrocarbons and helping deal with the catalyst, deal with CO and NOx. Now what it does is it pumps air into the manifold. You might have remembered seeing that on some of your GM cars and stuff back in the day, so that whenever that hydrocarbons from a cold start is coming out of there, what you got there is a situation where they put a little extra oxygen in there, and the hydrocarbons coming out of that are hot enough in that exhaust to where it finishes burning them up with that fresh air that you're pumping in there. That's what that's about. And then it goes downstream if it's needed to help the catalyst do the work that it does. And so that's what air injection reactor does. A lot of people would stop up these ports and get rid of that pump, which I always thought was kind of a bad idea. All right, older air injection systems had belt-driven pumps or pulse air valves. Pulse air valves take advantage of the low-pressure pulses in the exhaust system just to feather some in there. You know, it's pretty interesting how that works. Now, one other thing I will tell you about these, if you've got a bad check valve right here, and it manages to pump exhaust up in there to the back to those plastic valves and all that operate this stuff, it will definitely cause a big problem and melt those things down and all that, melt all them hoses, mess them all up. Also, if the thing is putting air into the exhaust when you're letting off, like back in the days when we had the carburetors and throttle body injection, a lot of gas would wind up sweating on the inside of the manifold. You let off the gas, the pressure drops, that would turn into a vapor, and it would go into the exhaust. And if it's going into the exhaust, you know, into all that heat, and the air system's putting air in there to make it backfire, you know. And so you could have, sometimes you might have heard exhaust going whoop, 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 and that's typically what's going on there. You can look for problems with the AIR system, particularly on the old ones if it's doing that. The newer AIR systems have got a pump. On your Volkswagens, they're mounted down there where they like to get damaged by water from splash and stuff. But anyway, that little pump right there is pretty cool to let them. And it basically operates the same way. All right, sequence of events. Vehicle starts. PCM determines coolant intake temp. Triggers secondary air pump relay to power up the pump. Grounds the secondary air solenoid. Intake vacuum travels through the combination valve. And so this is bolted to the manifold. There's your valve. There's your intake and all. And so there you go. If you borrow something from your employer without asking and never return it, is that the same as stealing? If it belongs to somebody else and you take it and keep it, you've ripped them off. Okay? All right, catalyst efficiency. Catalytic converters since 1975. They haven't always had oxygen sensors. They came around on American cars in the 80s. I think in 75, Saab was the first one to use an oxygen sensor. On there, they call it a lambda sensor, and they still do. Upstream oxygen sensors should be really active like that whenever you're driving or when you're into it. Downstream oxygen sensors should be lazy. That's an efficient catalyst. If they're switching together, the catalyst is not storing oxygen, it's bad. But what you got is you got HCCO and NOx going in, CO2 and H2O going out. CO2 doesn't hurt a dadgum thing. Most of the greenhouse gas in the atmosphere is water vapor. And you're not going to shoot down the clouds, and the CO2 is not going to make a bit of difference in this global warming they're talking about. Fuel trims, short and long, provide a correction factor to balance the mix when the combustion drifts too far out of line. Fuel trims will run near zero, not too far positive or negative on a healthy system. If I see double digits, I'm starting to be concerned about it, okay? Closed loop fuel control is the name of the game here. Perfect mix is the target of the system. So when it's paying attention to what the oxygen sensors are telling it, that's a closed loop. Open loop system would be like cold engine or a wide open throttle when you don't want it messing with your fuel mixture when you're passing a semi going up a hill and all that. But closed loop, there's a lot of closed loop systems. For example, my watch is not a closed loop system. It only knows what I tell it, right? A closed loop system is basically one where it can, like a thermostat on your house, where it can change things to make to satisfy its own measurements and all. All right, lambda works this way. More than one means a lean mix, less than one means a rich mix, if you're looking at lambda numbers. Fuel trim works this way. If it's correcting lean, it means it's got a rich mixture. If it's correcting rich, it means it's got a lean mixture. Vacuum leaks, canister purge issues, leaking injectors, you get it, not a big deal. Those rear sensors though, those rear catalyst efficiency sensors can affect fuel trim. So don't be fooled by that. If it can't trust the front one, it will use the back one because it's all about keeping the catalyst happy. Since that catalyst is guaranteed so long, they're making darn sure that they do whatever they have to and as much as they can to keep that catalyst from getting unhappy and too hot and messed up and so on and so forth. So they won't have to buy another one. If the front sensors are dead, it'll throw the fuel trim out of whack based on what the rear sensors are telling it. A lot of people don't know that. Now, you may almost never see that problem, but it's a potential threat. Fuel system monitor sets about 83. A perceived lean condition drives the fuel pilt wider. A perceived rich condition drives it down, narrower. The O2 sensors provide near instant after the fact analysis of what happened in the combustion chamber. If you put a scope on an oxygen sensor, and I had a little chamber I had screwed it into like an old piece of catalytic converter, and you just put that scope on there and you start heating that sensor up with a bottle torch and you start watching it, it'll go up. If you move that bottle torch off of it, it goes down immediately. You move it back and forth, it goes up and down, up and down. That's how fast that thing operates. It's incredible. Integrator is what they used to call short fuel trim. General Motors use that. Some of your European people use that. Block learn would be your long fuel trim. If you see these two terms, that's short fuel trim and long fuel trim. Cold start, key on engine coolant, air temperature and barometric pressure are measured with lightning speed. This happens real fast before you can even start it. Closed throttle voltage is noted. Crank sensor begins its output. Cam sensor inputs considered for injector timing. Injector is double pulse. To wet the manifold when the starter is operating, the engine starts. O2 sensors quickly bring the sensors up to the temperature required. This happens really fast. All right, within 60 seconds of starting, the modern system is in full-blown closed loop. Older ones took longer. Earlier oxygen sensors didn't even have a ground wire. They just used the ground from the manifold itself. PCM starts to monitor the O2 sensors and respond with fuel trim corrections. If an abnormal condition causes the fuel system to be too much out of balance, the short fuel trim may max out. If it does, the long fuel trim will start ratcheting up a little at a time until it gets to the point to where the short fuel trim can go back to zero. But it's holding it way out of balance using the long fuel trim. And that's really something. So what kind of condition would cause the readings displayed on the bottom? See that you got long fuel trim, bank 1, bank 2. If you think you fixed a problem when it's causing fuel trim, like say you find a vacuum leak or something and you say, oh, that's the reason for it. If you pull the battery terminals off while you're doing your repair, and of course if it's a Honda you're going to have the radio code, but you know about all that. Anyway, when you put it back on, and or if you can use your scan tool to do clear the fuel trim memory. Anyway, fire that thing up, watch it go into closed loop, and see if it immediately starts taking that thing, the short fuel trim, starts going crazy again. If it does, you hadn't fixed it. You still got a problem and you need to keep looking. So if you find a vacuum leak, don't clear the code and say to BI8. You need to make sure that you're doing it. A lot of shops require you to actually go and make sure it'll clear all the monitors, and that's not a bad practice. When repairing a too lean or too rich code, that's what I said, just covered that a second ago. Always reset to keep alive memory after performing a repair to clear any skewed data out of the tables. The PCM needs to start over with base data and relearn. Always view and record freeze frame data, which is an important snapshot of what was happening when the code was set. Newer systems will store freeze frame data for just about every code that appears. Now the Chrysler people with their DRB3 used to call it a similar conditions window. So you would know what was going on when the code was set, so you could try to go and duplicate that, right? Multiple diagnostic trouble codes with the same meaning are set for multiple sensors. It's unlikely that replacing both O2 sensors will resolve the concern. In most cases, there will be another issue that's causing the codes, like if both sensors are reading lean, or if both sensors are reading rich, then you got a deal like that. All right, freeze frame data is going to tell us, it's a little snapshot so you can get an idea how fast they were going, what the temperature of the engine was. That is basically what Chrysler was calling, I think, the similar conditions window when I went to Chrysler's because I'm on that. Anyway, I hope this has helped you guys out, and I really appreciate you watching and sending me encouraging comments. And I guess I'll see you next time.